Hello and welcome to What's Up with Energy, a gridX podcast. I'm your host, Georgia Knapp, and today I have with me two of our development team members who are going to explain a little bit more about what goes on behind the scenes of gridX and the actual technology coding side of it. So I have Wolfgang Werner and Chris Coltsman. If you two can just introduce yourselves and just a brief introduction of what you do at gridX. Wolfgang, you first.
Hi, I'm Wolfgang. I've been working in software development for the past 2 decades or a bit more in a variety of roles as a software engineer, as an engineering manager, as a consultant, as a software architect in different industries, manufacturing, utilities, finance, biotech, in different sizes of companies from pre-seed startups to Fortune 500s. And an engineering manager and responsible for 3 of our backend teams at gridX now.
And Chris?
Thank you for having us. I lead a development team, the Data Lake and Calculator, and been a software developer until I joined gridX for over 20 years and been a manager and a team lead since then. And really lucky position that I get to code a lot, so I haven't had to leave that behind me. I really enjoy that. It's been really exciting. It's been really exciting.
How would you describe the backbone of gridX's backend system? What makes it unique or challenging compared to other large-scale software infrastructures?
So I think one interesting part of what we do at gridX is like the sheer breadth of it. So we do some embedded software development and system level programming. We do a lot of like data ingestion and cloud edge communication stuff, in addition to the classic cloud web application or mobile development. And we also do that, right? We have like interesting like optimization problems. So there's like a lot of different disciplines that is actually, I find that quite impressive for a company of our size, that we like have do all this in-house basically. And that obviously also reflects into what kind of backend services we run. So the way it is built up, it's several multiple smaller services who interact that we run in the cloud, some specialized teams that deal with cloud edge connection or time series storage of time series data. And then we have like services that are more foundational, like master data management of the asset inventories that we manage, and some of the services that are more energy domain driven, like supporting time of use dynamic tariffs, supporting the flex market and whatever. And like all those services kind of form a mesh in a sense that like to fulfill the actual business properties of the system that we're building, right? And so several services interact towards that. I think another thing that is really interesting is that from my perspective, we learned that other companies have similar scale, but I think the amount of data that we handle and the number of requests that we're serving is quite impressive. So we're like having endpoints that are getting hit 100,000 times per second, 24/7, 365. So that's, in my world, that is significant scale. So,
is that like per grid box, or is that like including all of them out in the field?
That example, like the 100K request per second, is communication from all the grid boxes to ingest some data into the cloud. So the cloud part receives like these 100 requests per second from all the grid boxes that are deployed in the field.
Okay. And then Chris, how does Data Lake and Calculator fit into this ecosystem?
So we are responsible for receiving the time series data that the grid boxes are generating. So all of these assets on the fields are creating measurements, goes through the pipeline, goes through Wolfgang's systems, then it comes to us. Mm-hmm. And over the last 3 years since I've been here, we have grown the number of systems we have, are we 5 times larger? I'm not exactly sure how.
Factor of 12 actually in the last 2 years.
So that's been our biggest challenge, is
Scale.
how to scale cost effectively.
Yeah.
That's what my team challenged. I don't have as many. My scope is extremely narrow focused. Handling and managing this massive amount of data that's coming in cost effectively, using that data to generate lots of insights. So we receive the data, we process the data, we provide the live view for our customers. We calculate that data into the 15-minute historical data, which is the backbone of a lot of other things that we do at gridX. The time of use, flexibilities, all of this forecasting, all uses that data. So it's really important that this data is accurate, nothing's getting lost, it's available when it needs to be. And that's what my team has been working on for the past 3 years.
And then for both of you, how do your teams coordinate when backend logic and data infrastructure intersect? For example, when performance or schema changes both layers.
3 years ago, I would have said it was a really uncomfortable conversation of trying to find who is responsible for could give you permission to make these changes, trying to find the right people to communicate with. So Wolfgang and his team have done a great job over the last few years of actually trying to distribute ownership for these components. So he spent a lot of time refactoring it and creating ownership of the domains. And there was a time, my team, as I said, is highly focused on measurements and measurement processing. So we have a couple of API endpoints where we do that, right? You can fetch raw measurements. You can fetch the live view historical data. Ownership of those endpoints wasn't clear for a long time, which was quite frustrating for our PMs and when you wanted to have changes applied to that. And about a year ago, we just sat together and said, okay, you know what? Why don't my team just takes ownership of it. We have the most domain knowledge of this stuff, so we might as well do it.
Yeah.
Of course, it added more work to our team, but we were able to provide a great service because we know exactly what we're doing. We know if we're going to make a change, we can make it end-to-end now. We don't need to communicate with anyone anymore. Yeah. That's made us extremely fast, efficient. We take responsibility for the decisions that we make. Yeah? And if needed, though, we can use Wolfgang and his team for supporting. How do we, what is our strategy moving forward for API? How do we design our APIs effectively in that, right? So Wolfgang and his team have become very supportive in a supporting role for us and in enabling us to move quickly.
I think you can think of teams being structured along technical boundaries like front end, back end, or you can think of teams being structured along like fracture lines of the domain, basically. Saying like this team deals more with the EMS logic, this other team deals more with time series data or measurements, this other team deals with e-mobility and stuff. And you've been asking about interfaces between the teams and what you do by structuring teams along those domain boundaries is that you try to make teams as autonomous as possible, so you have less interfaces to other teams, right? Because then when you need to interface with another team, there's naturally more friction, right?
Yeah.
And so you might know of Conway's law. That's the concept that I think it's quite literally, it's an organization that produces software is constrained to producing software that mirrors the communication structures of that organization. So basically, if you have a team like that, your software will reflect that there is a component that mirrors the team, right? And now coming from team topologies, which is like a framework or tool of thinking about how to structure teams in tech companies, they coined the term inverse Conway maneuver, saying like, if your organization structure influences the architecture, then why not think about what kind of architecture you want to have and then model the teams around that architecture, right? So basically you turn it on its head, you turn Conway's law on its head, basically. And I think this is what we've been doing with quite some success. I mean, it's a long journey, but we see that reducing interfaces and making teams able to function more autonomously really pays off, even if it's a challenge for the teams to begin with, because they take on more responsibility.
Yeah.
But once they can cover the requirements basically that they have in the skill wise, right, they become very efficient and have just less communication overhead. And then there are still remaining interfaces, right? No team is an island still, and we have when services of different teams communicate with each other, we have formalized interfaces and can generate code from our interface specifications to make sure those matches. We tend to be very mindful of breaking changes in our APIs that would break stuff in other teams. And from a communication point of view, we have dedicated Slack channels for each team, and we always have one person responsible for looking out for support requests from other teams, so that not the whole team is taken up with paying attention what's going on around this team, but there's one person basically on call every time another team needs something. If you're on that rotation, okay, I'm going to deal with it, and everyone else knows, okay, I can focus on what I've been working on. So we get less context switches for most of the team most of the time.
When you inherit a legacy code, how do you decide whether to refactor, rebuild, leave it as it is?
So I think on one hand, legacy code always is the code that you wrote yesterday, right? So you always when you write something, then after you've written it, you know how you would write it the next time, so it would be a little bit better, right?
Okay.
And this stays true for every iteration, so you don't stop learning. You could always go back and change everything, right? But that's not a viable thing. You will never get anything finished if you proceed that way. So that's one part of it. The other part is that as a startup company, you start to grow, you produce code really quickly, and you try out ideas, right? And you try to find your product market fit, and then you throw feature ideas at the market and see what sticks, basically. And then if something sticks, then you're busy refining that, making that thing, that one feature scale better, for example. And then you don't clean up all the other experience that you made, right? So over time, some more of those experiments pile up, and then you will reuse one of those experiments in a slightly different context, and have some workarounds, right? And this piles up. And that's very natural. And you don't start optimizing for scale until you see some parts of the system really scale and requiring that scale. Because if you optimize everything, you'll end up with a lot of work and a system that is optimized in all the wrong places, basically, and complicated to work with. So having said that, we produced a lot of legacy code, and we have to live with that, and that's a natural thing. I think your original question was whether when we decide to rewrite or not rewrite something, I think pretty much every time making a complete rewrite from scratch is a bad idea. You always look for small incremental improvements with small risks attached, but you keep on doing them, and then they the effect of doing those small improvements, that's a compounding effect, basically. And you just need discipline to stay at that. And also you have to build an environment in which it is safe to make small changes and roll them out quickly. Sorry, and I'll stop and let you talk for a bit.
When I joined gridX, I had just gone through a major refactoring of the data processing, these measurements that we get in. Because part of our job is to manage, as we continue to grow, sometimes the decisions we've made in the past prove to be more expensive than we originally perhaps thought they would be.
Okay, yeah.
Right? So you have to then move quickly. You have to change things, refactor and re-architect them. Sometimes that is a completely rewriting and replacing something.
Mm-hmm.
Sometimes it's an a small change. So it's a weird feeling. I've never worked in a place where we work like we do here. This has been. I've always an advocate in the past for, let's rewrite it. Let's just start again and do that. I was always advocating for that because it felt like the easiest way to get rid of the legacy that we'd built up.
It's just rewrite from scratch.
Rewrite from scratch.
Okay.
And then I read a book called Kill It With Fire, which changed I think a lot of my philosophy on migrating from old systems to new systems.
You recommended that to me.
Yeah.
It's really brilliant.
So kudos to the author for that. And I introduced a lot of those concepts. So my team has gone through this. If I think back to where we are today, we've replaced a lot of systems with completely new ones.
Okay.
But we didn't do it in one shot. We did it small, incremental steps. Mm-hmm. We ran everything in parallel. So we would refactor, replace something new, something old with something new, but we would always run them at the same time, in parallel. We would measure, right? We had lots of observability around this stuff. So we can see, okay, is the new one operating better than the old one? Is it operating the way we expected it to? Are the results, right? If they're calculations, are the calculations the same?
Yeah.
If they're different, are they what we expected them to be? Right? That is on one hand, it is an additional cost because you're actually running sometimes infrastructure twice. Mm-hmm. But that is a short-term cost for a long-term gain. We had gained a lot of knowledge and experience, especially when you're working in code bases that you're not really familiar with. We've had incredible production stability. Quality is higher. The team feels really confident about deploying these changes if they've been running them in parallel for a while and they can see that it's working. They trust it. And then when we're ready, we can shut the old one off.
What are some of the biggest technical challenges you both have faced, especially as gridX has been scaling?
When I joined gridX, I had never worked with data like this before.
Mm-hmm.
I was intimidated by it, to be honest. Like, how do you go from not working with data to managing what at the time was a huge amount of data? Mm-hmm. Now I feel really comfortable with it. Over 3 years, just gaining experience with it. Yeah. Now I feel really comfortable. And now I have complete trust when we have 10 times the number of customers we have today. I trust in the systems that they will continue to work. Mm-hmm. We have the skills and the knowledge and experience that along the path, if any hiccups occur, we will manage them, we'll fix them, improve them, and we will continue to work. So,
yeah, I think we've been talking about refactoring legacy stuff, and we've been talking about scaling and having this at the same time, like significantly, the load of to our systems goes up significantly, is still going up linearly, but has been at some points really exploding, right? Mm-hmm. And we're refactoring the systems, making them more scalable while the load is growing steadily. That's pretty tough to do at the same time. Basically, we can't stop any one thing. So everything needs to keep working, needs to keep up with the load while we are improving it, right? So we have to come up with ways of not breaking any existing commitment, but still improving the performance and the throughput of our systems. And that is a super interesting challenge, I think. But it's also tough, and I think there's some tools that we employ for that. It's also nothing that we came up with, but it's pretty much industry standard that we run our stateless services in our cluster and can scale in and out dynamically, elastically based on which kinds of load patterns we're experiencing, favoring shared nothing architecture, so we can actually grow and shrink as the load demands, and that is kind of still challenging, but kind of think we're doing it quite well by now. It's like I think our observability has become so good that we see early warning signals before things are starting to break, right? And we can predict how much our load will go up based on the number of grid boxes that we sell. Basically, we know we manufacture them, we sell them. At some point, they will come online, right? And that is something that we can use to estimate how much the load goes up. And then we see, like, if something starts behaving differently than we expect in production, then we will look into that. And typically we catch like suboptimalities before they really break something. Then some parts of the system may react a bit slower for some time, and then we'll catch that, and then we'll improve that part to react quickly enough again, basically. And this is like very... like our observability tells us very decidedly where to look at, so we don't have to like optimize everything all at once, but we just like get good pointers where it pays off to optimize.
We primarily use Go, right? The language?
Yes.
Is that just one of the languages, or do we use Python?
I mean, we use Go for most of our backend services. We use some Python in the backend and for optimization and machine learning stuff. In the front end, we use JavaScript, TypeScript, React, the framework.
Is there, and again, this could be a dumb question to ask because maybe it's obvious, but like, is there a reason we use the languages that we do compared to, because there must be something else besides Go, Python?
I came from a Java background of 16 years, so I started learning Go when I got here. First, of course, ask yourself, why do we use Go? I couldn't tell you. I wasn't here when they made the decision. But I wouldn't want to go back to Java now. The turnaround time, the development time is so fast.
Okay.
It's night and day difference. I love. It's so much more enjoyable to work with. No offense, Java, in case you're listening.
I mean, I think it's like compiling down to native code to small native binaries makes it easy to distribute, and then you don't have like a virtual machine overhead while running as you would have in Java or have in Python. So then Go just does that really well and cross compiles really well. And in the front end, TypeScript actually compiles to JavaScript, but that's just a lingua franca for interactive user interfaces that run in the browser on the web. That's just like there's one additional reason for using Go is that it lends itself really well to write backend code, HTTP services and stuff, but it's also usable for system level development. So stuff that runs on the grid box as well, and for like driver development. And so we have like basically one language that we use across our stack in the backend, but also for the system level development on the edge. Which makes it easier for people to move around across teams, right? And like so you don't have a completely different stack if you're doing like cloud backends or working on the edge.
Yeah.
At least use the same language.
Okay. For both of you, how do you balance innovation and new features with the constant need to remain available and secure?
I'm a big fan of Kanban.
Of what?
Kanban.
Kanban?
Yep.
What's that?
Have you ever heard of Scrum?
I've heard the word, yes.
Okay. So Scrum, you typically would plan for maybe for the next year, all the work you're going to work on for the next 2 weeks or 3 weeks or 4 weeks in your sprints. So in Kanban, we don't do that. In Kanban, every day we focus on what is the most important things to be working on.
Okay.
Right? So every day, if something comes in, a new feature request comes in from one of the other teams, we can start working on it. As soon as the other task we're currently working on is done, we can start working on it. If while we're working on that task, something breaks in production, we can stop that, start immediately working on fixing something in production, and when that's done, go back to the task we're currently working on. No new planning required, no replanning, no commitments being broken for things that we haven't delivered yet because we haven't committed to anything. We simply commit to ourselves and to everyone else in the organization. We will always work on what is the most important thing to be working on. And if you come up with something else, we will focus on that. We can pivot very quickly. We don't have to ask anyone. We don't have to ask any stakeholders. We don't have to say, okay, what are the consequences if we change our plan or anything like that? Because we haven't committed to anything. We do commit and said, okay, if we start working on something, we can give you a rough estimate of how long it would take us to develop it, because how long does it take us, generally speaking, to develop new features, right? But my experience over the years is that that's really hard to make a plan and stick with it, right? So I really like the flexibility of Kanban. It simply says every day, all the time, just work on whatever is the most important thing.
And I think in terms of experimenting with new technologies or new approaches, new languages, frameworks, whatever, one thing is that we can run experiments in parallel, as Chris outlined. We can try to build some part of our system in a new, more experimental, more shiny way that we don't really know whether we want to go there, and have it run in parallel, right? Working off production data and comparing results. You have been doing this for quite some time for when you change the way we receive measurements, right?
Yep. And we're changing it again. We're currently in another refactoring, we're completely replacing or rewriting one part of the way we do measurement handling. And we're doing it piece by piece, small chunks at a time, implementing it, measuring it, running them in parallel. Is it operating as we expected it to? And when we feel confident, we switch over.
This means we can experiment on production data without jeopardizing production operations. We just run it in parallel, right? Yeah. And there are always opportunities to try out things in parts that are not directly related to the product, but in internal tooling, internal management tools or operational tools or stuff that we build and just make our own lives easier, that we can always experiment, right? If you don't jeopardize production. That brings me to some kind of mindset, which I think we have and in which we like to work, is that we're not you've been working on that for 9 months, but it wasn't exactly like you had this one super clear cut goal, super well defined, and then you just went backward and broke it down, right? But I think it's more of a goal cloud, goal potential basically, and then then you look also very tactically what to do next, right? And then sometimes things just play out well. There is something that you need to do in daily business because some component behaves in a certain way or some feature is requested, and then you just pick your tasks or define your tasks in a way that you move slowly but not very directly into the direction of this still a bit fuzzy goal, and you kind of meander your way towards that goal, right? And you just balance the short-term requirements that come in with a long-term strategic direction. And this gives you a lot of flexibility to react in a very short periods of time, and not stick to this very detailed, rigorous plan, right? And that also opens up a lot of possibility for experimentation, because you can just you don't go very straight and you do a small detour or a small other detour, and you might up at a slightly different place than you originally imagined, but at a place that's more appropriate to be in given the requirements that you have. That makes any sense?
Yeah, no, that does. And it reminds me a lot of what do you call it, the adage, slow and steady wins the race. You said the slow winding meander rather than just trying to go from point A to point B as fast as possible.
Yeah. I try to go from point A to point B as quickly as possible, but we do it in small, steady steps.
Yeah.
Fast is slow, slow is fast.
I think that's actually a good place to stop and move into the rapid fire questions. This one, I feel like I know the answer to, and if you guys don't say what I think you're going to say, I'm going to be surprised.
Okay.
Dark mode or light mode?
Both.
Both.
When presenting dark mode, generally light mode. There's actually science that when presenting or making slides or something, then I'm in dark mode because then people think I'm a hacker and people think hackers use dark mode. Actually, there is science that backs up that light mode is actually easier to read, better on the eyes and stuff. Yeah.
Interesting. Okay. You guys did answer. I thought you were both just going to be like dark mode, move on. Okay.
That's why I use dark mode in presentations.
What's your favorite programming language, even if it's an unpopular one?
Okay, maybe controversial opinion. I really like TypeScript a lot. I like the TypeScript's type system.
Okay.
I also like Kotlin a lot because it balances like this functional programming versus a more pragmatic approach quite well. So, yeah.
I wouldn't call your answer rapid fire. At the moment, I'm really enjoying Go. I'm still learning.
Okay.
A lot.
If your code base were a movie genre, which would it be?
Romantic comedy.
Dystopian horror.
Two very different genres.
I think it's probably somewhere in the middle, though.
Which tool or shortcut could you not live without?
I have some key bindings to manage for my window management, so I can just shove windows around between screens and resize them, and that comes in super handy.
That's an interesting question. I don't have no idea. I really like the code completion in Goland now. So I think that's just actually I can't even remember which code combination it is to accept it. Tab to accept it.
Is it command space?
You start typing something and then you want to accept it. You just push the arrow, I think, to get you to the end of the line. Tab or I don't even remember anymore.
Muscle memory.
It's just come. Just do it now. I don't even think about it.
And then, if you could instantly master one new tech skill, what would it be?
There, I would have to say, people, not technical skill.
Okay.
This job is more about people than it is technical.
Interesting. Okay.
And I would like to. I'm still so fascinated by people organizing, people coming together as a team, how to organize them to move in one direction as a team, thinking about the team and not just themselves. Technical is only a small portion of what we do on every day. It's mostly about people.
Yeah.
And as a team lead now for 3 years, I'm so fascinated by this topic. And high-performing teams, creating high-performing teams, absolutely so fascinated by this, and I love it.
Nice.
Yeah, I agree. It's like technology is like a challenge, but not the biggest challenge, I guess. Okay. I think I would like to really get product management and like figuring out from looking at the market, talking to people, what exactly to build. I think this is incredibly hard to do good or to do well. That's something that I would like to know better than, to be very proficient in, I guess.
Yeah.
Because I see like so many product managers struggling across all the companies I've worked with, and I saw like product management is really, really, really hard. And like having this worked out, that would be amazing.
Great. Well, thank you both for joining me on the podcast. I hope a lot of our tech listeners learned a lot.
Thank you for having us.
Yeah, thanks for having us.
If you'd like to learn more about the world of renewable energy or energy management systems, be sure to check out our website, gridX.ai, where we produce regular blogs and glossaries about the subject. You can also follow us on LinkedIn or on Twitter and Instagram at GetGridX.